Today we are multiplying polynomials, and for the first time, I assume. Before you go about this, you might want to remember some things from, well, let's say pre-algebra. You need to know how to multiply monomials. I'll give you a couple quick examples of that. Here's a monomial, 5x squared. And here's another one, 10x to the third. The multiplication symbol, a dot or an asterisk, is absent here. And of course, we don't want to use an x either. So often people will use parentheses to denote multiplication. But the idea here is you want to make sure you multiply the 5 and the 10. 5 times 10 is 50. And then you are multiplying a lot of x's together. Okay, this quite literally means x times x. This is a multiplication of 3 factors of x. So you have x times x times x times x times x. How many x's was that? That was 5. And of course, a shortcut to this is just to say 2 plus 3 is 5. Now, the nice thing about multiplying monomials, I can't think of a situation where there's no answer. In other words, you can always do this. Let's take another example. 3x multiplied by 12x to the fourth. So thinking about what we just said, we have these numbers in front here. They're called coefficients, and we want to multiply those. 3 times 12 is 36. And then as far as x factors go, let's count them up. There's x times x times x times x times x. I counted 5 factors of x. Now a shortcut, again, is to do this. Just put a 1 here. That's the default exponent. And add the 1 and the 4. So you get x to the 5th. So again, you're multiplying these coefficients. And then for the power of x, you're going to add the exponents. Now, sometimes it's not quite as obvious. For example, if I had 4x times 8, this is the product of 2 monomials. You're going to go ahead and multiply 4 times 8. That's 32. What do you do with that x? Well, it's a factor that needs to come along for the ride, so you just write it down here. 32x. And we are multiplying monomials. I think that covers it pretty well. Let's do one more. What do you do about negative 2x times positive 5x? Okay, remember a negative times a positive makes a negative, so negative 2 times 5 is negative 10. And then we have x times x, that is 2 factors of x, and that is what this notation means right here. X squared is x times x. Multiply monomials. Now, contrast that with adding and subtracting monomials. I think this is a little more complicated, but we'll start simple. Let's start with 5x plus 2x. It's a lot like adding 5 and 2 apples. You get 7 of whatever you had in the first place. X terms, I'll call them x terms. If I ask you to add 5x and 2y, I'm asking you to do the impossible. Those can't be added. They're not what we call like terms. So one of the rules is you have to have the same variable. Another rule, though, is that you also have to have the same exponent if there happens to be an exponent. So if I have 3y squared plus 8y squared, I can go ahead and add these. They both have y, and they both have the same exponent of 2. 3 plus 8 is 11. And the answer is 11y squared. It's not to the 4th power. I could not get a 4th power unless I had y times y times y times y. But I don't have multiplication there. So again, the rule is you have to have the same variable, and you have to have the same exponent, and then you have to retain that exponent for the answer. Subtraction is pretty much the same thing. If you have 12z to the third minus 4z to the third, we can go ahead and do this. both of these two terms are filled with z factors, and they both have the same exponent, which is 3. So 12 minus 4 is 8. Retain the exponent, 8z to the third power. Next and final thing I think you need to know before we move to today's topic is make sure you know how to multiply through a sum or a difference. This is called distribution. I'll just do one example of this, maybe two. If you have 5 times 2x plus 4, you want to make sure you multiply 5 times 2 and include the x, you get 10x. Well, that's just multiplying monomials if you think about it. But now you also have 5 times 4. So quite literally you have two jobs to do, a multiplication here, which we've completed, and a multiplication here. You have two things to do, two multiplications, because there are two terms inside of this sum. Let's do ones a little more complicated here. What if on the outside I have 3x squared, and in here I have what's called a trinomial. So it has 1, 2, 3 terms. This distribution requires 3 multiplications. You're going to have to multiply these. So just ignore everything else for a minute. If I were multiplying these monomials, I'd get 15, right? And I would also get x to the what? Would it stay 2 power or go up to 4th power? Yes, you do 2 plus 2 is 4th power. Why do you do that? Because you are multiplying this power of x times that. And when you're multiplying powers, the exponent can build up to a 4th power like that. Think of it this way. X times x times x times x. There's 4 factors of x. 3 times 2 is 6. It's actually a negative 6. The power on x here is going to be a 3rd power because it's 1, 2, 3 factors of x. You could also just say 2 plus 1. Finally, down here, we're going to have 3 times 4 is 12. And we're going to have x squared, which came from here. Okay, now we can move on to what we really wanted to talk about. We can multiply polynomials. And we're going to start off easy. A binomial times a binomial. This is considered a binomial because it has two things being added, a y and a 6. This is also a binomial, y plus 4. We're multiplying these two binomials. What you want to do, what I have found is, you're going to have basically 4 multiplications you have to do. So pretend for a minute that you don't have the 6 here, and you're just multiplying through by y. What's y times y? Y squared. What's y times 4? 4y. Now we're all done with this y because we've used it twice. So what I would do is cover it up and pretend it's not there so it's not a distraction. You've got 2 more multiplications to do, a distribution with this 6. 6 times the y and 6 times the 4. Now 6 times y is 6y, and I'm going to write that right here. And 6 times 4 is 24. I like to put my answers in 3 columns because very often there's a column that has a square factor of y or x. There's a column that has no x or y whatsoever, and in the middle, very often there will be 2 terms that are both what are called linear terms. They both have exponents of 1, and you don't have to show those. Okay, so what do we get? We get 3 answers to form a trinomial. We get y squared. We get 10y. Remember, the power doesn't go up because we're not multiplying these y's. And then we get 24. All right, let's pick up the pace and go a little faster. This next problem has z minus 5 times z plus 3, product of 2 binomials. Cover up this negative 5. Act like it's not even there. Multiply through with this z. And make sure you hit both of these. So you have two jobs to do. You have z times z. You have z times 3. Then you're done with that z, and you should cover it up. You have negative 5 times z, and you have negative 5 times 3. What do you get when you total these? Well, the only math you still need to do, I guess, would be right here in the z column, because z squared is not going to combine with anything. There are no other z squared terms. Likewise, this 15 can't combine with any of these z terms because 15 doesn't have a z. But you can put these two together. 3 minus 5 is negative 2. Negative 2z or minus 2z, and then minus 15. Now, this is a video you're watching. If you think you get the hang of it, you should pause the video, try the next problem, turn it back on, see if you got it right. I'm going to keep moving. Cover up this 1. Multiply through by 3k. Hit both the 4k and the 9 with a multiplication of a 3k. Ready? 3k times 4k is 12k squared. 3k times 9 is 27k. Now cover up 3k and multiply through with negative 1. Negative 1 times 4 is negative 4. Don't forget to put the k factor on there. Negative 1 times 9 is negative 9. Time for totals. We have 12k squared in the k squared column. 27 minus 4 is 23. And finally, we have minus 9 as a solitary number out there. Getting the hang of this? Again, we're at the point where you should pause the video and try the next problem before I do it. This one, in the first binomial, the x term and the non-x term seem to be a little bit out of order. That's okay. We're going to proceed as we always have. Multiply with this 8 and hit both the 2x and the 6. 8 times 2 is 6. Or excuse me, 16. And 8 times 6 is 48. Now multiply through with negative 4x. Yes, the minus sign acts like a negative and it belongs to the 4. Now, negative 4 times negative 2 is negative 8, and x times x is x squared. And I'm going to put that one column in front of this x term. I like to keep the highest powers of x up front. So that took care of this, and then negative 4x times 6 is minus 24x. Now, if you have any doubt about this 16 up here was a positive. So when I total that middle column, I'm going to have 16 minus 24. All right, here's my answer. Negative 8x squared. 16 minus 24 is negative 8. It's not x squared. We're not doing x times x here. We're doing x minus x, basically, plus 48. Now, in this next problem, we have two binomials. But the second binomial has some higher powers of v. So we're going to have to remember what we said about multiplying monomials today. Let's get started. Cover up this 3, multiply through with a v. V times v squared is v times v times v. That's v to the third. The cube of v. V times v here is v squared. There's also an 8. So it's 8v squared. Now I'm multiplying through with 3. 3 times v squared is v squared. There's a minus involved. And I'm going to put that in the v squared column, like that. Finally, 3 times 8 is 24. It's a minus or a negative 24, and there's a v attached. So in the previous problem, we had x squared, x, and no x at all. This time we have v cubed, v squared, and v. Everything is one power higher than the problems you've seen today so far. e to the third. 8 minus 3 is 5. And minus 24b. Okay. If you're a student of mine listening in, these next 4 problems are going to come later in our learning, but I thought I'd go ahead and show you how they work now. No time like the present. They're still products of binomials, but some special things happen. Notice how these binomials look pretty much exactly the same. They both have the x, they both have the 10, but one says minus and one says plus. Something interesting happens when you have this arrangement. And by the way, these have a name. They are called conjugates. They have a very important role in mathematics. Today you get to see what happens when you multiply conjugates. Okay, cover up the 10. Multiply through with x. X times x is x squared. X times 10 is 10x. Now multiply through with the 10, but it's a negative 10. Now 10 times x is still 10x, but with a minus sign it looks like this. And 10 times 10 is 100 with a minus. Well, you can see what's going to happen here. When I get to the x column, I have 10 minus 10, and that makes 0. You should not write x. You really shouldn't write 0x, although that would be correct. Here's the point. When in life you get to 0, it really doesn't matter what you were counting anymore. It doesn't matter if it was $10 bills, pencils, apples. They're gone. And in this case, the x's are all gone. So I'm not going to put anything in the x column. I'm just going to write x squared minus 100. And what was it that was special that happened? Yeah, these two terms canceled. And for the first time today, we got an answer that did not look like a 1, 2, 3 term trinomial. We got an answer that looked like a binomial. We're going to see that again with this problem because, again, these are conjugates. They look exactly the same. Z cubed, 5, 5. But this has plus and this has minus. So what happens when you multiply those? You're not going to get a trinomial. Let's take a look. Z to the third times z to the third is z to the 3 plus 3 is 6 power z to the 6th. Z to the third times 5 is 5z to the third. There's a minus sign on there. And then multiplied through with this 5. 5 times z to the third is 5z to the third. And 5 times 5 is 25. And in the z column, or the z to the third column, excuse me, we get total cancellation. 5 minus 5 is 0. So the only thing that shows up in the answer is z to the 6th and 25. And what you should notice is, similar to the last problem, this is only a binomial. Both these problems had minus signs. Both of these problems have even power on the variable. And both of these problems end with a perfect square. This is 10 times 10, or 10 squared. This is 5 times 5, or 5 squared. Okay, I showed you a couple of those. We have one more special pattern here to show you, 2 examples of it. What happens when the binomials look exactly the same? Do you get this cancellation here? No, you don't. But you get a pattern that's special enough that it's worth studying. When you multiply through by x, you get x squared. Of course you do. Multiply through by x here, you get 9x. Now, multiply through by 9, and instead of cancellation here, you get another exact copy, or a doubling of what that one was. So 9x comes here, and 9 times 9 is 81. And now we total this up. X squared, 18 in the x column, and 81 here. So this is called a perfect square trinomial. It starts with a square, x squared. It ends with a square. 9 squared is 81. And the middle term is the double of either this multiplication or that multiplication. I'll do this next one very quickly, and then I'll show you a bonus problem. Okay, 3y squared times 3y squared is 9y to the 4th power. Yes, the power does go up because we're multiplying. 3y squared times 4 is 12y squared. You're going to get another copy of 12y squared here, but this time it's minus. So, we're back to looking at conjugates here. I don't think I intended to make this problem conjugates, but it is, so we're going to go with it. We get 9y to the 4th. We get the y squared terms completely canceling out, and then we get 16 with a minus sign. Okay. Now, where's that bonus problem? You get to multiply a binomial times a trinomial. Just one example. And if you're my student, this is not going to be on my quiz, so skip it if you wish. But let's go. Cover up the 5. Multiply through with the 2x. Okay, you get to do that 3 times, though. 3 times. It's 2x times 3x squared. It's 2x times 2x. And it's 2x times 5. Then you get to multiply through with the 5. 5 times 3 is 15. You'll have an x squared attached to this, which means you should put it right here in this column. 5 times 2 is 10. And 5 times 5 is 25. Let's look at the totals. 6x cubed. 15 minus 4 is 11. X squared, not x to the 4th. It looks like in the x column, everything's going to cancel, so I won't bother. And I'll write 25 down and slide it over here next to the other terms, and there's the answer. Okay, multiplying mostly binomials today, and one example of a trinomial. Have a good day.